Hello everyone, and welcome to today's webinar on how to get started with connected field service, hosted by Copperberg and PTC. My name is Thomas Igu and I'm the content director at Copperberg. Copperberg is the leading organizer of business platforms for service leaders in Europe, organizing events throughout the year on service management, spare parts, field service, IoT, and pricing excellence. I'm joined today by Michael Anderson, who is the Field Service Management Solutions Director at PTC. Michael, glad to have you. Also with us, we're very glad to have Martin Gill. Martin is the Senior Vice President of Global Service at Electr. Great to have you as well, Martin.
Thank you.
For information, a recorded version of this webinar will be available for download on both Copperberg and PTC websites, and we'll be also sending a link to the webinar on demand later on. We'd also love to hear from you today. We will have a live Q&A segment to conclude the webinar, but don't hesitate to submit your questions during the presentations in your GoToWebinar control panel. We'll try to cover as many questions as possible. However, if because of time constraints we are unable to, we'll be answering your questions post-webinar via email. So for those of you joining us just now, welcome to the Copperberg and PTC webinar on how to get started with field service, with a special case study from Electr. Now, to get started, we ran a survey at Copperberg on connected service to better understand the trends impacting manufacturers, the state of service businesses today, and the biggest advantages and challenges around connectivity. It was quite interesting to see the statistics on trends impacting the manufacturing industry. We really see with digitization, globalization, and connectivity that they're true game changers and really driving this fourth industrial revolution. They've completely broken down the barriers of traditional manufacturing. Today, you don't compete with traditional competitors for customers with traditional demands. We all know of the Ubers and Airbnbs and how they've disrupted entire industries. So it's no surprise to see these figures at such a high level, but it's quite interesting to see digitization impacting 83% of manufacturers, globalization at 62%, and connectivity at 58%. When we look at connecting service business, two interesting facts, and kind of actually showing the gap as well from theory to practice. A staggering 86% of respondents feel that their company's corporate objective includes a vision that supports digitizing the service business. However, 54% in practice then feel that they don't have the right skill set internally today to truly connect their service business. So we see the gap between corporate vision and reality in manufacturing today when it comes to internal skill sets. When we look at service businesses today, today you want to be selling on performance and you want to be predictive, but we see that we're far from there yet. Only 18% are selling on performance and only 8% are predictive. Especially when it comes to reactive businesses, actually a quite high number, 55% of organizations today still feel that they are reactive, and 35% are still selling machines and services in silos. When it comes to opportunities when connecting your service business, and Michael and Martin will go in greater details on those, they're actually quite customer-facing. Of course, some of the most obvious opportunities look at preventing downtime for customers, also creating dynamic service offerings, so being able to offer different types of options to your customers, because of course not everyone will value actually predictive maintenance because of their nature of the business or the cost of the service. Also, reducing labor costs for both vendor and customer. New business opportunities arising from the vast amount of data that's collected and being able to transform that into new opportunities. Ability to cross-sell on different product lines and services. Connectivity is also creating a differentiator to increase the long-term loyalty of the customers, and also allows manufacturers to gain knowledge on their customer behavior and usage of equipment, which allows them to develop customized services. And also for some manufacturers, especially that have a model where they deal primarily with dealers, it actually allows a closer relationships with your end customers, because you're able to interact directly with them. When we look at the biggest challenges, most of them on the flip side are actually internal. Number one challenge was the IT support to connect legacy equipment to the internet. A lot of manufacturing companies are very old organizations, 100+ years, with a lot of traditions, a lot of equipments that are 20, 30, 40 years or older. So to be able to connect all of those legacy equipment to the internet is a challenge for many. Then there is the internal barriers, how to convince top management to go that route. Mindset internally, how to change the mindset not only of your division, but also R&D and sales and marketing to approach a new way of conducting business. And as previously discussed, new skill sets required. Then of course, data is both an advantage but a challenge, and able to manage and crunch data and create usable information is a challenge for many. To gather data is not such a challenge anymore, but to be able to make sense of the data and use it is quite a challenge. And then, of course, there's the cybersecurity aspect, especially when we look at data protection and regulations in Europe and other parts of the world. When it comes to customers, having real feedback to long-term initiatives and finding customers who are ready to invest in a new type of service offering. And I guess this touches as well into your ability to be able to communicate to your customers the value of your new service offerings. And this links as well to having also a new type of business model. And of course, the challenge as well is the speed of change of the process, because change management is a long-term effort. So these were the results from the survey. You'll be able to get a more comprehensive survey result later on. But now I would like to pass over to Michael.
Thanks, Thomas. I'm just getting this screen shared. Great. So thanks, Thomas. That's an interesting survey and really touched same to. And you know, the nature of service really is fundamentally, manufacturers nowadays want service really to provide that significant for their business. IDC reports that manufacturers want to capture 30% of their revenue from services, and a Salesforce survey also shows that 74% of manufacturing executives identified service as a really significant driver of future revenues. So in order to generate significant revenue, we must adapt to increasing customer expectations. 92% of executives polled by Salesforce want their organizations to adapt service strategies to better reflect their customer needs. And for manufacturers to drive this unprecedented in their organization, they're transforming their entire service model and are using IoT as an enabler. We know that 50 billion IoT assets will be deployed in the next 5 years. An essential role an essential role in enabling manufacturers to outperform competition by delivering information that allows for more sophisticated service offerings. This means contextual data, smart assets, and the way that companies compete. Machine learning, predictive analytics, and augmented reality are going to create even more disruption. Technological innovations means not only falling behind the competition, but also potentially losing ground until recovery is impossible. So with new service models and IoT, the potential for new revenue is really endless. But these new demands on service present some challenges. OEMs are losing significant parts revenue to competitors while working in a very reactive mode, resulting in high-cost on-site service. Find the right service information. Service parts inventory is larger than needed. And ability to scale your service operations. This is all while customers are demanding enhanced services and outcome-based contracts. These customers may perceive that the total cost of ownership is too high, perhaps experience. Customers commonly view the OEM parts vendor as the OEM as a parts vendor rather than a strategic partner, which really is value drivers. All while service is tasked with driving more revenue and profit. So your competitors are already thinking about including being able to remotely access, enabling remote service and remote updates, and optimizing parts forecasting and pricing. Your competitors are also thinking about how connected that they service their equipment today, tracking and monitoring product location, performance. You always know where your products are and how they're performing. Enabling remote service and remote software updates, routine placed by remote service, software update solution. You can also optimize your parts forecasting and pricing through causal forecast. Inventory is more effectively planned.
Michael, we seem to have a little problem with your audio. Do you think you could be able to switch your audio source? I don't know if you're using your phone or your computer, but switch from one to the other.
Sure, I can switch. Give me just a second. Thomas, is this better?
It seems, if you speak a bit more, because sometimes you're fading a bit, and apologies to everyone watching for this technical issue.
Sorry about that. So I was saying that very soon it's also going to fundamentally change the way that service is done in the future. Oops. So it will be really empowering technicians with up-to-date content and augmented reality, virtual reality guidance. Technician visits, when necessary, are far more efficient with operational and service information overlaid on the asset. Applying connectivity and predictive analytics in order to drive proactive service and automate scheduling, product maintenance issues are identified and can be fixed before they occur. So PTC and ServiceMax have partnered to enable manufacturers and service organizations to profitably grow their business by differentiating their service offerings and transforming to these outcome-based services. We accomplish this by integrating our industry-leading IoT, field service and SLM solutions to enable smart connected service for smart connected products. So as I walk through some of the capabilities of connected field service, I want you to think about your connected product strategy and the benefits of adopting connected service. And specifically think about how connected service can reduce your mean time to repair, increase your technician efficiency, increase your first-time fix rate, lower the cost of service, and improve your customer satisfaction. So connected field service can help you deliver proactive service, leveraging data from connected products for improved service, support, and usability. For example, you may proactively monitor a product, identify issues, and fix it before it breaks. It improves the customer experience, resulting in a longer relationship. Connected field service can also optimize your technician workforce. This is really all about efficiency and taking cost or time out of an organization, combining real-time data with existing systems to increase efficiency. For example, if you have data about a product's condition, you can reduce the time it takes a technician to troubleshoot or reduce the number of visits required to repair, improving that first-time fix rate. A connected product strategy will allow you to differentiate your offerings. By understanding and monitoring the way your products are being used, you can reduce the risks necessary to provide outcome-based contracts. This allows you to provide your customer with a higher level of service, opening up new revenue streams. So let's dig a bit deeper into delivering proactive service. With proactive service, you can auto-create service jobs when exception conditions are detected. These exception conditions can be based on threshold alerts like a temperature too high or pressure too low. Could be defined based on anomaly detection, monitoring sensors for abnormal behavior, or even using predictive analytics, analyzing that historical data to predict and prevent future failures. The work scope can be created based on the alert and the diagnostics model so that the right action can be taken based on the issue. Technicians receive service instructions and interactive 3D models, allowing the service to be more easily understood and performed. Collecting real-time data about the issue improves the accuracy of data capture and improves the diagnostics process. Delivering proactive service results in improving your technician productivity and increasing that customer satisfaction. You can deliver your service quickly and accurately. You can optimize your technician workforce by providing your technicians with all the information they need to fix the issue right the first time. Automated diagnostics quickly narrow down the problem. Contextual repair documents provide the technician quick access to the right documentation. Providing remote access to technicians reduces expensive on-site visits. Technicians can run scripts or commands. They can perform bidirectional file transfers to download and inspect log files or upload new configurations. And they can make software and firmware updates remotely. All of this lowers the cost of service, improves your technician productivity, and increases your customer satisfaction. Now that you have connected your services, you're able to truly differentiate your service offerings, providing rich maintenance plans, new SLA tiers, all while maximizing price and profit and building a competitive differentiator. You can start to offer products as a service where you measure and deliver outcomes to your customers instead of the traditional product. This can allow you to transform your business model and establish market leadership. Connected services really allow you to mitigate the risk of outcome-based offerings, all while improving service revenue and customer satisfaction. So connected field service is the offering that provides that ability to create machine-initiated service requests when exceptions are detected, to view real-time and historical data for your connected products, to remotely connect to your products, automate the diagnostics, and provide the technician the right repair procedures in the context of the asset and the issue so that he always has the right information right at his fingertips. Enabling these capabilities allows you to decrease the average time to repair, increase your first-time fix rate, improve your technician productivity, and provide your customers with the outcome-based services that they're demanding while maintaining a profitable service operation. So I'd encourage you to listen as Martin with Electr talks about how they've been able to successfully implement connected services and improve their service offerings and customer satisfaction. You'll see how you can deliver more proactive service and reduce your mean time to repair. Optimize your technician workforce, lower your cost of service, and really differentiate your service offering and create new sources of revenue. So now I'm going to turn it over to Mark.
Okay, thank you, Michael. Good afternoon, good morning, everyone. My name is Martin Gill, and I'm the Senior Vice President for Global Service for Electr. Today, I'd like to talk to you about how Electr has used connected systems and the Internet of Things to develop enhanced services for our customers, but also to look at how we can reduce the cost of our service delivery function. And you'll see as I go through this case study that many of the points that Michael has brought out already we're putting into practice here. So just a couple of slides on Electr. So Electr is a Swedish medical technology company, and the systems that we produce are used to treat cancer and brain disorders with radiation therapy. So the machine that you can see in this picture is a linear accelerator, our primary radiation therapy system. So there's over 3,000 of these systems installed around the world. Electr has been at the forefront of radiation therapy and product development for over 40 years, and the product range covers all areas of radiation treatment. Head, neck, and brain treatment is delivered with the Gamma Knife system that's shown here on the right-hand side of this slide. Brachytherapy systems deliver the radiation source inside the body using specialist applicators, and they're also used for treating skin cancer, as shown here. And then the linear accelerator system, this is a system called the Versa HD. This treats multiple body sites for cancer. And then on the left-hand side, the latest research project, which combines a linear accelerator with advanced MRI imaging. And then running all of these systems, oncology informatics is the application that manages the full radiation therapy workflow, and the treatment planning application is used by the clinical staff to determine the precise treatment solution that needs to be delivered to that particular patient. Let me just explain a little bit about how this is used, and you'll realize later on some of the impacts of the importance of the service organization. So radiation therapy treatment can vary considerably, but often a course of treatment is delivered in very short sessions. So maybe 10 to 15 minutes of radiation treatment for a patient, but they're receiving that every day for maybe 5 or 6 weeks. As you can imagine, this means that many patients will be scheduled for treatment on a single machine in any one day. If there's 10 to 15 minute treatments, there's many people, patients that are scheduled to have treatments on that machine. And so a system failure can have a significant customer and patient impact. And hence our service methodology is aimed at preventing problems from interrupting the patient schedule, which is where the Internet of Things and predictive maintenance comes to the fore. So first of all, Michael talked about some of the changes in the service business and the expectation that service delivers significantly both to the revenue and the profitability of an organization. So the development of a services culture and in the organization is really the foundation for any development of advanced services. As you can see, our company is a very product and technology-led business, but actually the service business needs to demonstrate its contribution. In order to get the investment or the resources assigned to development of these advanced services, service has to be seen as a fundamental part of the business as well, even in a strong product company. So a clear and effective governance process, a focus on growth, and taking responsibility for driving relationships with R&D and product management, because that's where a lot of this actually starts. And of course, effective collaboration with the other parts of the organization. But I focused here particularly on R&D and product management, because I think this collaboration is really essential. And this is really what we did to try to help that collaboration. Rather like, I think most of you would recognize that sales and service guys, they're looking after the same customers, but they often don't see eye to eye. They don't always talk the same language. I think that's also true of R&D and service. They can talk about the same problem, but they don't necessarily understand each function's responsibility towards resolving those problems. So enabling the organization to communicate effectively is really important. In our case, we recruited a head of what we called installed base engineering. This person was an expert in design for service, and really we supported then the development and the investment around design for service, and this really improved the communication channel between the two groups and led to the development of things like lifecycle costing models, reliability-centered maintenance initiatives, those sorts of things. And then to expand the thinking around IoT opportunities, we ran a number of workshops to develop new ideas outside of the service environment. And then service also had a place at the product development table. So really we were championing serviceability improvements and reporting back on performance in the field. So over the last few years, we've developed what we called our global service delivery model. You know, this isn't rocket science. Most of you, I think, will recognize this sort of a model. It's a single point of entry for customer incidents and requests, core routing to the appropriate agents who can start working on the customer problem. But we also included reactive, proactive, and predictive remote support activity as part of the workflow. And I'll talk to more about these subjects later on. I've highlighted in this chart the remote support and assist at the initial stage of receiving the customer call. And then we go through the normal service management, using knowledge management, having a logistics platform, standard escalations, etc. And then coming around to the remote command center and active monitoring of our installed base. Of course, without your systems being connected, it's not possible to take advantage of the remote support capability. And so we've had a very strong drive in the last few years on connecting our systems. I would say approximately 2 years ago, we had less than 50% of our systems connected, and today we're almost at 80%. I think it's exactly 79% of the install base is connected. And the real importance of that is moving to a majority connected base enables the development of an enhanced support model. So really, in the past, when we had less than half of the base connected, you were almost forced into a more reactive model. It was about how quickly you could get to the customer site or resolve the problem. When you're in a majority connected mode, then you can move your strategy towards a more proactive and a predictive sort of methodology. And we drove that really across all of our geographic regions. Those slides you saw, we have some business intelligence applications. We measure those as those metrics for connectivity as KPIs. It's part of our monthly service review governance. And so with a connected installed base, or the majority connected, this is where we've got to so far. There was really 3 types of remote support. Reactive support is immediate response to a customer issue while they're on the phone. So when a customer calls in, we identify whether they're connected or not. We ask them if we can initiate a connection. While the machine is streaming data to us all of the time, we can't take any activity on the machine without the customer enabling us. So that's an important security aspect. So the customer enables the investigative connection, shall we say, and our help desk agent can start analyzing the problem that he can see on the machine, he or she can see on the machine. And from a cost perspective, this has been a really big cost saver for us. So as you can see, over 25% of our customer calls are now resolved without an on-site visit. And we're talking about essentially hardware calls here. So this is not about software support. This is where the customer believes that there's a hardware fault. Now, obviously, there may be or there may not be. If it's a broken component, then clearly you need to go to site for that. But many of the issues related to adjustments or configuration or operator issues, they can be resolved remotely. The second phase is around proactive support. So this is alerting field service engineers to predetermined machine conditions. So we have a remote application. The application identifies when certain thresholds have been breached in the machine, and we can use those thresholds or a combination of them to automatically alert the engineer to a problem. So either we can message him or we can email him to say machine 1234 in customer ABC has actually triggered a remote alert. It isn't necessarily a serious problem with the machine, but it may be indicative that a problem is beginning to develop. The engineer then has the ability to call in himself, so he can call in from anywhere in the world and connect to that machine, and he'll carry out a more thorough health check of the machine and determine whether further action is required. And then the real exciting part of it, I think, is predictive support. So this is where we're monitoring the devices and identifying a set of conditions that accurately predict a near-term failure. So when this situation occurs, we raise a case or a ticket in our service management system and schedule time on the customer system before a failure will interrupt the clinical schedule. So we have, as you can imagine, there are many failure modes in a complex machine like this. And today we probably have about 5 or 6 specific use cases where we can accurately predict a failure. So if we see these set of conditions, we know that a failure is going to occur within the next 2 to 3 weeks. And therefore we have, the objective then is to be able to intervene and to take action on that machine before it interrupts the clinical schedule. And I've got a couple of examples with this. As we've been developing this, One of the more difficult areas of the machine is the vacuum system. So the radiation beam travels through a vacuum system. If you have a problem on the vacuum system and the whole system gets contaminated, it is a sort of pretty much a complete rebuild of that system with a lot of parts. So this is one that can really potentially save us a lot of time. But in developing this capability, we had examples where we were able to prevent a failure, and then we had identical issues where, for whatever reason, we did not get to the customer's system in time. This enabled us to do a direct comparison between a repair associated with a predicted failure and one where we did not get there in time and an unscheduled failure occurred. So the incident shown here is a specific incident on a customer machine with the vacuum system, and as I said, a fundamental part of the machine. And in this particular case, the machine was down for more than 5 clinical days. We did not get to this machine in time. We obviously used a lot of parts to repair the machine, and there was a lot of engineering hours in actually bringing the machine back to use. Compare that to a situation, a pretty similar graph. This was a different machine in a different country, the identical use case where the failure was predicted, and we were able to schedule repair time with the customer. And bearing in mind, when we're scheduling this time with the customer, typically this will be outside of the clinical day. And so no patients are impacted by this. So either we'll do this in the evening or we'll do this at weekend. So the result here was that the machine was down for a much shorter period of time. We used less parts, and the repair was much more straightforward. Again, the experience of the engineer is quite significant here, and you need a very competent engineer to repair this. So in comparing these two situations, the hospital downtime, customer downtime, was reduced by 75%. We saved more than 50% in both spare parts costs and in labor hours. So that was truly a win-win situation. Increased availability for the customer, lower cost to us, and obviously being able to schedule a service event rather than having to deal with an unscheduled one. Now, as I said, there are many failure use cases in the machine, and we have a relatively small number that we're working on now, but we are using them all the time. They truly work. But it goes back to that really important development, that really important relationship that I talked about earlier with R&D. Because in order to develop additional use cases in other parts of the machine, we need to be able to capture the data from within the machine that's going to enable us to analyze the problem and to make this the next predictive use case. So we've got 20 or 30 use cases or potential use cases that are waiting to be implemented in our next product releases. So then if we go on to further develop the connected field service and the system integration that Michael was talking about, today most of our activity is relatively manual. We have people, technicians who are monitoring the performance of the machines, getting the data streaming from the machines into our application, determining whether any of these use cases are triggered. But in future, further advances will enable us to connect the machine directly to our remote service application, and then from there directly into our service management system through the PTC platform and into ServiceMax. So effectively, this will be the machine calling home and saying, I've got a problem that's developing. It is going to cause me to fail within a short period of time. Please treat this as an urgent attention. So today, in future, these advantages in connected field service will be able to automate that end-to-end process for us, which means that we'll be able to monitor the whole base. So finally, if you're just starting on your connected service journey, what I would recommend, you don't need to go in a big bang change here. Start small, but think big about what you want to achieve. You only need 1 or 2 high-value use cases to get momentum in the organization. You do need some people who are passionate about the subject to champion the activity, and especially to engage R&D and product management. But once the ball is rolling, I think you'll find that there are many applications for IoT technology, both within and outside of service. IoT does not recognize functional silos, and while the overall use case for service may be the most obvious one, when you start thinking about, in our case, how we could connect this data to other data systems in the hospital to help the customers towards, outcome-based service, there's many other opportunities. And one of the primary KPIs in our case for the customer, or the outcome for the customer, is about patient throughput. So all of our development is focused on improving that patient throughput for our customer and maximizing the availability of the system. So thank you very much, and with that, I'll hand back to Thomas.
Thank you very much, Martin. So it was actually a very interesting case study, which got a lot of questions from the audience. So I will take up the questions now with you, Martin.
Okay.
Our first question was, how were you able to connect the service information used by the field service engineer to the data coming from IoT?
Okay, so really this is, we've been working on the development of remote service for a number of years. So it is actually the development of our own remote service application. We call it IntelliMax. And it started, I would say it started a number of years ago, where within the device, there were a number of data points that were primarily there for the benefit of R&D. We took that data, we analyzed it related to service issues, and we developed our application to be able to identify those alerts which were particularly relevant to service. But it is really the development of our remote support application.
Okay. We had another question, which is also a bit on your business model, and it's a 2- or 3-part question actually. Does Electr work with many distributors? And if yes, how did the connectability campaign work out with them? Was that a requirement of a service level agreement contract?
Okay. The majority of our service, so approximately 70% of our service, is delivered directly by Electr service engineers. However, there are many countries around the world which, for various reasons, we will use distributors and service partners. There isn't a requirement to connect to the systems, but even in those circumstances, wherever we can connect to the end user system, we will, because what typically happens in those distributor countries, the distributor will be a sales organization in that country, and often there are service organization as well, and they will provide, first and second line service support. But if they're unable to resolve a problem, we generally sell the distributor a support package. So for tier 3 or tier 4 support, if the distributor says, we need your help as the manufacturer, we'll provide that help, and we're able to connect into the end user system, perhaps with the distributor engineer on site, and provide some over-the-shoulder support for the distributor. So it's very much, added support for the distributor or the service partner.
Okay. Well, another area I think that intrigued the audience quite a lot was your initiative to hire a head of installed base engineering. We did have a question, or actually two questions from two different attendees about your install base that was designed before the appointment of the install base engineering manager. So did you upgrade those units for connectivity and for remote diagnostic, and what was your customer approach to do so?
Yeah, so the very early machines weren't able to be connected, so the focus was really to upgrade those machines. And to be honest, the life of a linear accelerator machine is around 10 to 12 years, and so we're looking to upgrade those machines. And of course, all of the later machines all had the ability to be connected, whether they were or not with something else, but they all had the ability to connect. But I think maybe to the more general point was, as a very product-focused company for many years, I think the focus was on product development and functionality development, and it wasn't necessarily on serviceability and other remote capability in the machine. And so when the new head of install base engineering came along, and we focused on design for service and design for installation, that really helped us to drive the whole remote service story, both within our own organization, but also with the customer base.
Yeah.
I hope that's answered the question.
Yeah. Okay, and well, another question, at what time did you create the predictive models? Is it during development or after product delivery as part of lifecycle management?
Yes, it's really after product delivery, because with the machines that are connected, we can go back to quite old machines now. As long as we're collecting the data, then we can use that data and put it into our application to identify those particular data points. So it's something, as long as the machine is connected, we can go back to quite old machines. It's not just the new machines that have that capability.
Yeah. Okay. Well, another question, and your question, your presentation got a lot of questions, so hopefully we'll have time to go through all of them. Again, otherwise, any ones that we miss, we'll follow up by email with an answer afterwards. But Martin, is your system log file the main enabler for predictive service? And how do you protect this intellectual property, since customers own this information, especially against third-party providers?
No, the main data is not the log file, no, but it's very specific data points within the machine. So, and what we're collecting is machine data. So we're not collecting any other data. We're not collecting any hospital data or patient data or anything like that. It is simply machine data points, which are then being interpreted. So it's really doing a similar thing to what the engineer would do if he was on site, but maybe with some advantages. And I guess what we've done in recent times with the development in R&D, if we see something that if we know we need to collect that vacuum pressure or that current or that voltage there, we make that data available to the remote service agent that allows us then to collect and harvest that data from the install base.
Yeah. And another question, how are you investing in capability development of service engineers?
Yeah, that's a good question, and that's always a challenge, right? And that's why I would say the ongoing relationship between the product management, product development team and service is a continual one. We need to in service to really demonstrate the value of further development and investment in R&D. We need to demonstrate the value to our customers and to our service organization, and this obviously, particularly in the predictive side, can be quite a differentiator as well. If we can really drive the volume here, this could be quite a differentiator for us against our competition. But then you're always competing for resources who are, focused on developing the latest and greatest advance in the actual technology itself. So I talked about that project that's ongoing at the moment to combine the linear accelerator with MRI imaging. That's obviously taking a lot of R&D resource, and rightfully so. It's going to be a very innovative product, but we need to compete for that same resource within R&D to say, okay, well, we would really wish to have development in this area of the machine as well, because it's going to enable us to be predictive about this problem, and that problem is going to increase the uptime for the customer by X%, and it's going to reduce our cost of service by Y%. So I think it's really an ongoing discussion with the teams in there.
But and which team in your organization is able to analyze the vacuum data and take action? Is it on a country or global engineering team?
We have both really. So there's a central team. So I've got the remote services development, a small team working entirely on that subject. They're working with our service delivery teams in each of the geographic regions, and in the help desk operations, we call it Electr support. We have Electr support centers in the US, in Europe, in Asia, and in that help desk environment, we have hardware support experts. They're taking calls from customers and doing the reactive support, but in between times, they're also monitoring devices in their particular territory and trying to predict some of those failures in advance of the customer interruption. So I'd say we've got both a central and a decentralized model.
Yeah. Well, when it comes to the charging model, or kind of, do you work on the subscription base, or kind of a one-time yearly fee, or is it on a fix every time you have to go ahead and do a fix, or how is your charging model?
The majority of our customer contracts are service, annual or multi-year service contracts. But now maybe that raises another important point. To help with connectivity, we actually charge the customer a premium now if they do not connect or do not allow connection to our remote service. Yeah. Obviously, it's more expensive for us to deliver service if we're unable to connect to the customer's machine, and so the annual maintenance charge is uplifted if there isn't any connectivity. Okay.
Another question is, can you remotely control and change settings on the machine?
Yes, we can, albeit only in association with the customer. And there is also a limited number of changes that we can make remotely. But for example, there's a water system. We can change the temperature setting, for example, on the machine, which is related to the warm-up time of the machine. So there's some limited adjustment that we can do, but only with the customer. The other challenge here, obviously, is the medical device. This is a highly regulated environment, and any change needs to have quality assurance by the customer after such a change. So those will only be carried out in association with the customer.
Yeah, and how do you measure and keep track on critical wear parts?
We have, it goes back to sort of reliability-centered maintenance, and there are a number of measurements that we can take, whether it's high tension hours, whether it's rotations of the whole drum, or whether it's the amount of usage in a particular part of the machine. I would say that does inform some of our maintenance methodology, but that's also in relatively early stages of development. I think we've focused more on being able to get the data from the machine that is going to tell us of the condition, as opposed to counting the amount of usage in order to estimate when that particular part of the machine or component is nearing its end of life.
Okay. Well, another question is how do you persuade your customers and hospitals, in essence, to connect their products and to allow this data sharing? Is it a challenge, or do they really see the value from the beginning? Is it a lot of convincing to do?
Yes, I would say it is a challenge. I mean, it's something that we've invested a lot of time on because of the benefit that obviously this would give us. But we're dealing with two groups. Initially, we're dealing with the hospital IT management, and I would say, quite often there is pushback from the IT team. They're obviously concerned about security. So I think the first requirement was for us to be able to try to convince the IT team that we have, secure interfaces and firewalls. We're not going to put anything onto their intranet. And so some of the time that's successful and we can connect. When IT really push back and won't allow connection, what we found works for us is to use customers who will endorse the use of remote support. So from the clinical staff. So if we talk to the oncologist or the physicist in charge of the machine, the ones who've experienced a reactive or a proactive or a predictive engagement can really see the value of maximizing the uptime of their system. And so we've used those customers to help us to persuade the IT organization that this is really a big benefit to the hospital from their own reimbursement methodology, from their patient throughput, from their outcomes. So we've really used the outcome that the customer sees as a lever really to help the hospital staff see the benefit of a connected solution.
Yeah, okay. I will take one last question because of time constraints. And again, any additional questions we have not answered to, we'll get back privately via email. But my last question actually kind of related to your to the beginning of your presentation, where you talked about the development of a service culture and how that is the foundation to anything, and kind of your need to demonstrate the contribution of the service department to the overall organization. how, and of course it's a long answer, but in just a minute, how did you do that? How did you show you were fundamental, and how did you manage top management and other departments to even hire a head of install base engineering and to work on this?
Yeah, that's a very good question. It probably is quite a long answer, but I'll try and make it short. I guess those people who, some people will be, in a product-focused company, some people will be in a service-focused company, and I think if you're a manufacturer, often the product focus does get the priority. And in service, we can often complain that we're not given the investment in R&D, or we're not, designing in serviceability or extra reliability into the product. But equally, we're not that strong on presenting a really positive business case, which is what is going to make the difference to the company. So that was really what I meant at the beginning, where we need to have the courage to say, okay, well, when we put this in place, it is going to reduce our costs by 10, 15, 20%, or it is going to grow some extra revenue because of the customer satisfaction with it. And we've got to be prepared to put those commitments into our budgets in order to demonstrate, I think, our commitment, to the cause, so to speak. So I think in many cases, service has perhaps played second fiddle to the product development, but we've almost allowed ourselves to be in that position. And I think we've got to take a bolder position and say, no, we really do want this investment. However, we're prepared to commit to the change that it is going to make to the service P&L and the profitability of the company. Okay,
great. Well, Martin and Michael, thank you both very much for both of your presentations. It was very insightful. I hope you, the audience, learned today how to get started with connected field service. This webinar will be available on demand, both on PTC websites, where you can also learn more about PTC service solutions. You can visit www.ptc.com. And the webinar will also be available on Copperberg website, where you can learn more about our service-related conferences. So please visit www.copperberg.com. We will also be replying to the questions which we were not able to answer. I know there were quite a few, privately by email later in the week. And otherwise, again, Martin, Michael, thank you both very much, and have a good rest of the day. This was Thomas and Gill from Copperberg.
Thanks, Thomas.
Thank you. Bye-bye.
Bye.